Hello everyone, my name is Priyal Himanshu Kapade, and today I'm going to explain the solid principles of designing. Object-oriented designing. These are like, okay, so let me start with this is not the topic which we would in proper study in our unit. But if we study these things, like we haven't got any particular task based on this topic, but what if but if we study this thing, then all the tasks which we are going to do ahead will become much more easier. We will understand it way better than how we usually do it. And it is a lot helpful being a good coder. Okay. So let's get started. The first thing is, wait, okay. Yep. So why solid? Um, the first the okay. So why solid is because the writing a good code is easy. Writing a code is easy. Like we can code the logic. We all know that we have got good logics in our mind. But to design it properly is hard. And this is the reason why this solid principles are created. So solid is like five principles for clean, scalable, maintainable code. So let's move to the first principle, which is single responsibility principle. Now, what is single responsibility principle? It says that a class should only have one job. Like in the bed, like let's give one example. See, over here I have made a diagram. So I'll start with explaining the diagram. As we know in the bad example, the report has got a report is a class which handles everything, loading, formatting, and printing all at the once. But what makes it not good is it is unorganized, it is cluttered, and the tasks are not distributed properly. So the first rule of the solid principle says that single responsibility principle, which is we should divide one class for one job. That is, over here we have then created report data, report formatter, and report printer. And why does this work? Because report data would only get the data. Report formatter will only have the logic to format the data, and report printer will only print the data. So this is what makes our code better. Yeah, the first code would have done the same thing, but it would not be reliable, it would not be organized, it would be clustered. Now let's move to the next principle. That is, wait, let me just, yep, let's move to the next principle, open closed principle. So what is open closed principle? What it states over here is that classes should be open for extension but closed for modification, which means that see, over here in the bed example, I've shown shape which has got, and then which has got circle, square, and triangle. So why is it bad? Because every time we would try to add a new shape, we must edit shape class. Like it, every time we would add a new shape, we would have to edit the existing shape code. And not, so it would, it would work, but it would not be reliable again. To edit this shape code is not as good is not as good way of coding. Rather than in the good example I have shown, that we can make, what we can either do is that make the shape class abstract, and then followed by different classes which has got circle, square, and triangle. So what helps over here is that in this shape, when the shape is abstract, and each shape type like circle, square, which can be overridden, which might have overridden methods called area, and hence we can put a particular logic for that particular shape in that particular class. So what happened over here is we have followed two principles. The first one is open, and the first one which we studied, that is one class is equals to one job. And now over here, the 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 abstract shape class is open for extension, but it is closed for modification. So this is how two rules are made, and it would make our code much more reliable. Now let's move to the next topic, that is next principle, that is Liskov substitution principle. So what happens over here is that the subclasses must be usable anywhere their parent is expected. So in the bad example, let me explain you with this example. That is, in the bad example, we have got bird, and which is followed by sparrow and penguin. Okay, so what happens over here is that in the bird class, we might put up a few methods which can say fly, what it eats, and what sounds does it make. We have this task in the future task. So this is the reason I have particularly took this example, so that when we move to the task in real, then we have this concept built in ourselves so that it becomes easier. We have this principles built ourselves so that it becomes easier to code. So over here, the bird has sparrow and penguin. What happens over here is that bird, in the bird class, we might define a method called fly. Sparrow can fly, but penguin cannot fly. So it is not one of the best examples, because the bird violates the because the penguin violates the bird's behavior. So what we can do is that, which I have explained in good example over here, that is, the bird is made abstract. So, and we will learn about abstract classes in the future class. So, I'm not going into detail about that because even I am not particularly sure, but I can. I'm just using this as an example to explain this principle. So what we can do over here is that make the bird class abstract, and then and then we can make two other classes called flying and non-flying bird, and then divide the flying birds into sparrow, eagle, and non-flying birds into penguin, ostrich. So by till now over here, what we have done is, like, we have followed three principles. The first one being one class one job, that is over here bird class is doing just one job, that is making it abstract so that a few methods are defined, and which are always followed whenever the child class would inherit it. And then flying bird has only one job, that is to show that which birds fly. And the non-flying birds has one job, to print they does not fly. And now sparrow and eagle has only one job, to show their characteristics. And penguin and ostrich has their one job, that is showing their characteristics. So this is how all these principles makes our code better. And this is the reason, and this is the reason it is important for us to understand this principle. Um, let's move to the next. Okay, let me just firstly complete this thing, that why does this good example, why is the good example worth it? Like, why is it good? What makes it good? Okay, so it's like, the subclasses grouped correctly, like the subclasses are grouped correctly, without breaking their expectations. Now I have got a few code written. I have studied C sharp. I, like, do not get overwhelmed by anything, but because in my last trimester I studied this thing, I'm using it. Do not get overwhelmed. We are going to learn this thing in the next task. So I have got a few examples. So over here in the code example, you can see that the class bird has got a virtual method fly, and now the sparrow is inheriting bird. It can fly high, but the penguin is also, so what we need to do is, penguin is also inheriting bird, which penguin cannot fly, right? So it is not one of the best examples. What we can either do is make the class bird class abstract, and then call the and then make one other class called flying bird, which would inherit the abstract bird class. And then inside flying bird, we can use sparrow. We can make sparrow inherit the flying bird, which means that sparrow is the child class and flying bird is the parent class. Like, I'm just trying to explain over here is, make sure we do one job at one time. This is what makes our code reusable and reliable. So let's move to the next principle, that is interface segregation principle. So over here, the best why the best thing about this is that instead of forcing classes to implement large interfaces, we are going to do this interface thing in the like last we are I guess last somewhere near last thing, because I saw this in the on track class on track tasks list. So I thought I'll add this as well. Um, let's not get overwhelmed. I'm just trying to explain principles because neither am I sure of what is happening. But I'm just trying to explain this principle so that whenever we all try to um, go to the task in like the real task, we know what we are doing. So interface segregation is more like instead of forcing classes to implement large interfaces, we should use smaller ones focused on smaller and focused ones. So like in the bad example, you can see that I machine has got everything: print, scan, fax, and then the simple printer we are using. So what would happen is that even if we just want to print, it would forcefully implement scan and fix fax as well. So what I did was, rather what we can do is make three different interfaces, that is I scanner, I printer, and I fax, and then inherit that thing as per needed, like as per the cases, however we need, we can do it. So instead of doing this, what we did over here was this thing, that I printer simple printer which will inherit iPrinter. So this is what makes it better. I have written this code example. If anybody wants, they can access this PPT and I'll share it to them. And then there is dependency inversion principle, which means that like it depends on abstractions and not the details. Like high level modules should not rely on low level ones. In the bad example, you can see that email services has only got one thing. That is, why is it a bad example? Firstly, because high level module depends on low level details. Like it is tightly coupled, which is hard to test and replace. So this is the reason why it is bad example. Instead, rather what we can do is, in the good example, what I did was I created one class called email services, which has email I interface called iMail sender, and then it has got two other subclasses, which has got STMP mail and then console mail. So this is how we can structure our code and make it more reliable. I have got the code. Anybody wants, they can just access it. I'm not explaining this because right now it is not needed, but it is a good idea to go through this code. I have gone through this code. If you want, you guys can do it as well. And the last thing, why solid matters, because it makes it makes the code easier to test. And then the other thing is flexible for changes. Like for the first example, we use shape, and then we had circle, everything cluttered. So if we want to add one more thing, we have to change everything inside the shape. Rather, when in the good example we saw that shape and then circle, triangle, square, okay, I'm telling it is a good thing, okay. So listen to me. And then it is flexible for changes, encourages reuse, and then reduce bugs as well. It is easier for us to debug. I can only suggest you guys, okay, do whatever you want at the end. So this was my explanation of solid principles. I hope this helps. See ya.